Yeah, cheers, Chris. My talk is completely different, and I was just saying I've not really prepared many visual cues, so I've got some notes on my phone I might have to defer to as I go through. But my name's Chris. I'm a volunteer here, but also I'm a lead software consultant, whatever that means these days. Sorry?
You went forward and back.
Yeah. Oh, yeah. Testing it works. But I am, as part of my job now, I do a lot of coaching for things like platform engineering, DevOps, and continuous delivery. So I go into a company with the team, and we'll try and improve their DORA maturity and all that stuff, all that consultancy stuff, right? So, and something we come up against quite a lot is infrastructure automation. It's something that a lot of companies are still very far behind on. And I think DevOps as a culture, people are talking about platform engineering. I think a lot of companies are still a decade behind DevOps. So from lots of Terraform tutoring, I've had some learnings on the best way to get it through to back-end engineers, and I want to bring those to you today. So this, hope you're all familiar with, never have I ever. We're going to start off with that. If I'm going to approach this like I am the perfect, just started software engineering, never had to do anything other than automated infrastructure, and if you're not acquainted with the game, it's usually a drinking game. So I'll say something I've not done. If you've done it, well, yeah, you drink. I think I'm partially responsible for your safety. So Josh said I can't make it a drinking game. So just put your hand up if you relate to any of these things. So never have I ever struggled to deploy infrastructure changes between environments, especially long releases. Never have I ever had to spin up a clone of an environment from scratch, like pen tests. Oh, the worst. Never have I ever struggled to revert infrastructure changes from a failed deployment. I'm not going to lie and say that's something I don't struggle with every day now, but it's got a lot better. And I think this one, tongue-in-cheek, but never have I ever wasted time waiting for a DevOps engineer to make a really simple infrastructure application level change that I just need to get to work. And I know what it is, but somebody else has to do it. So hopefully you're all holding at least one painful memory experience in mind. And I'm going to take you through Terraform. So what is Terraform? At its core, it's just a CLI tool. You install it on your machine or on a build agent. It takes configuration code as input, and the output is your infrastructure for your application. There's a lot of stuff around the ecosystem with Terraform from HashiCorp, things like Terraform Cloud. You don't need to worry about any of that for the purpose of this talk. And we're going to focus mainly on cloud infrastructure. So you write some code, you tell it what cloud infrastructure you want, it deploys it to the cloud. Amazing. So I think the biggest stumbling block when I try and bring engineers on board with Terraform is the difference between imperative and declarative code. And this is probably not going to be something new to anyone here, but C# is a multi-paradigm language. Imperative and declarative programming are two different paradigms, but I'd wager that most people here, most of your time you spend writing imperative code. And that is, imperative code is, how do you reach your end goal? It's, I've got two examples here, an imperative and a declarative example in C#. So I like to think of declarative program as kind of like a higher level of abstraction. You don't really care how it gets done. You just tell the thing what your end goal is. Great example is SQL. Anyone's written a SQL query, you're saying, give me these columns from this table, join to this, where it's this. I don't care what the SQL engine does. I don't care what indexes you use or what the query plan is. That's all up to you. This is just what I want. And this is important because Terraform HCL is predominantly, it's a declarative language, and it comes with so many benefits, but it's so hard to wrap your head around when you're writing imperative code and you switch into a declarative IAC language. So I hope that all makes sense. Does that make sense? It did in my head when I started talking. Yeah. Okay, amazing. So what's it look like? I've kept you all in suspense for long enough now. Terraform actually looks quite hideous. But the reason I wanted to talk about it is because it's so pervasive in the industry. And I think the reason is, on a bit of a tangent here, but more like, I guess, old school infrastructure configuration was like YAML, XML, config files. So to bring those professionals into the industry and along on this journey, Terraform made a lot of sense because it's a much more advanced version of that. So it looks something, actually this is what I'm going to make. So I've got this probably really common, really basic two-tier architecture. We've got a website running on Azure App Service, and we've got a SQL database on Azure SQL. And it looks like this. So this is a module called Azure App Service SQL. And high level here, what we're doing is we're taking in a variable called resource group name, and we're given an output called database URL. And from that input and output in between, we're creating this architecture on the right. So this is where I think, so what I'm going to do is try and run you through Terraform as you would look at it as a C# developer, which is what I found works really well with mentoring new engineers Terraform. Think of a module in Terraform as a function in C#, right? And you're just telling it, I'm going to give you this variable when I call you, which is the resource group name. I'm going to create these resources, and then when I'm finished, I'm going to give you these outputs. And I'm not going to go too much into detail on this today, but modules are the most basic level of composition in Terraform. You can compose them all together. They are just folders with Terraform files in. They're really, really dumb, and there's no file naming conventions. Every file in a folder is part of a module in Terraform. So, but we don't really need to know that for now. So what's going on here? We get the variable, we say, Terraform, I want a SQL server on version 12 with these credentials. You're then telling it, I want an MS SQL database that is on this server. If you see the cool little dependency we've got there called .NET Liverpool MS SQL database. And then I want to spin up an Azure web app, which will take that database URL as a connection string. So caveat here, none of this Terraform will compile. If you were to do this in production, this would go off the screen because you'd be configuring a lot more things. There's no app service plan on here. How will this ever run? There's no container image. But I wanted to show like a really basic, simple version of a skeleton of what this would look like. And they're the three main resources you would be focused on anyway. And Terraform does the rest. It's magic. You tell it what you want. You run Terraform apply. There's steps in between where you obviously got to configure it to tell it where you want it to deploy to, right? Your Azure credentials, stuff like that. And at the other end, it spits out some infrastructure. In that case, it'll give us a DB server, a database on that server, and an Azure web app. And there's three main commands that you'd use. I'm not going to go into them because I think today I just want to talk quickly about the concepts in Terraform, not how the CLI works, but these are quite self-explanatory. Plan will tell you what it would do. Apply would actually do the thing. Destroy would destroy all of the resources. Pointed this out earlier. Something really important with Terraform is how you can build sort of implicit dependencies between resources. So we are creating a MS SQL server, and we're also creating a database, and we're telling it that it needs to be on that server we've just created. And then if you look down, that animation took me so long, I wasn't going to do it for the other one. Like, that's the extent of my skills there. But the other one's more important, probably line 27. We are creating the database, and we're feeding that database connection string into the Azure web app. So think about how easy it is to spin up. You could run this module for every environment that you have. There's no manual plugging in of all your connection strings. It all happens automatically. Obviously, don't do this in a production environment. So you'd want to use Key Vault or something like that, or some secret store. But again, simple example. So this is where I think where I wanted to focus on today. What do these things mean if you're a C# developer? Like I've dragged people in with no Terraform experience to a call before and went, look, just make this change. And they've gone, I don't understand what this is. But it's actually, because it's so verbose and it's declarative, it's really easy to read. Like once you sit down and you go, oh, this is what it's actually doing. It's creating the server. Like if you wanted to make a change to this and configure something on the database or something like that, it's actually quite intuitive. You'd look at the docs, you'd find the property, you'd set the property, you'd push it up to probably your nicely oiled CI/CD pipeline. So over here, I've written complete nonsense. This will do nothing. It's some empty C# records. But this is how I like to think about Terraform in the C# world. So I said earlier, a function, like a module in Terraform, is a function in C#. You give it parameters, and it gives you back outputs, right? Within a function, there's different types of configuration blocks. Today, we're just looking at variables, resources, and outputs. All the most important ones you need to know about. You give it a variable, so you can obviously think about giving it a different environment name as well, all your different environment configurations, so you can deploy this automatically across all your different Azure subscriptions and all of that. So resources are kind of like objects. Think about it like the resource is telling Terraform this is going to be an object. The first parameter, that Azure RM MSQL server, is like a class in C#. This is the type of resource you're creating. The third parameter, the main DB server, that is the name, the local name of that Terraform resource. And that's so you can reference it within your Terraform files and do all that cool stuff with dependencies. And then you can think about the stuff between the curly brackets, like an object initializer or a constructor. So that's what I'm doing over there. I'm passing my MS SQL server instance some parameters to the constructor. And then beyond that, you've also got like the concept of referencing outputs from other objects. So if you look at line 17, where I am referencing the database, the main DB server.id, I never pass an ID in that's generated for me. It's an output from that resource. So you can plug everything together. It's really cool. And obviously at the end, I'm returning something that's like an output in Terraform. So I think they are all of the parallels. Modules are very interesting to understand. I wish I'd prepared some like visuals for it, but they're folders. You can compose different modules. When you run Terraform, all you need to do is go to an entry point module. Every module that references will also be used as well. You just need to provide the variables for that entry point module when you call Terraform, which you can do via the CLI or via variable input files. Right, so I said this would be a quick one. The benefits of Terraform. Coming full circle now, back to that, and never have I ever. What do we get out of it? So I think this is just talking about like fallibility, right? If I'm doing something manually across 3 environments, I'm almost certainly eventually going to forget something, do something in the wrong order, do something wrong. Terraform doesn't really have this problem. Obviously, you write the configuration wrong, it's going to be wrong in all the environments, but it's consistent. So, which is sort of next point, the determinism of Terraform. If one of your environments comes out of sync with Terraform, someone does a manual change, Terraform will spot that and it will get rid of that straight away. This idea of having ephemeral environments, spinning them up, destroying them really quickly, great for cost saving, great for speed as well, like ad hoc pen tests. Some of the industries I work in, that's a big thing. They won't go near even test environments for pen tests because of legal things, but this is great. It's great for us to go like, here's your environment for the day, now it's gone. And I think something that doesn't get appreciated enough is, now these benefits apply mostly to all IAC. Terraform is the most pervasive, but not the only IAC out there. You've got cloud-specific ones. You've got like more imperative ones like CDK, and I think Bicep is an Azure one. You've got like CloudFormation. You've got a really cool open source one called Pulumi, which has an SDK for loads of languages. But with declarative IAC like Terraform, it's self-documenting. Like I've found so many times going into a client and being like, right, what's going on here? They won't give me access to the environment. I can just go and look at Terraform and be like, oh, sick, that's how everything works and gets mapped together. And there are, because it is so structured, there are tools to generate documentation as well. So graphs of your infrastructure from documentation, it's amazing. I don't need to explain the benefits of source control, hopefully to everyone, but all the benefits of your code being source controlled, you get with your infrastructure as well. But it's amazing. Something as well, probably most of us don't really care about, but the automated policy and compliance. There hasn't got to be an architecture review board sitting there telling you, you can't do this, you can't create that because it's not secure. You can codify all of your security policies, your compliance policies, everything, and run it through your IAC. Speed as well, so fast. Like especially if you have big, large gaps between releases, trying to deploy a month's worth of infrastructure changes, Terraform, fast as the API will let it go. And automated testing. This is something I think that's better for imperative IAC, from my experience, because it's almost like, because it's self-documenting, you don't really need to write tests. You're writing a test to say, does it look like how I said it should look like? But for unit tests especially. But there are integration test frameworks with Terraform, which are great as well. So you can actually go and test what I've just deployed. Is it there? Did I do it right? And automated rollbacks. I think without that, that's the biggest thing. Once we show clients that if something gets messed up, we can pick a point in time for that Terraform through source control and go straight back to that point in time. It's not always that easy. How do you do that with a database that's just started getting some data? But I think for the most part, when you do quick releases, it's a huge confidence booster. So yeah, write Terraform. Any questions? Go.
Automated compliance, is that, are you talking like just code review, or is it like tools that will say you can't do that one?
Yeah, loads of tools for it. So like things like Chekhov, if anyone's heard of Chekhov, you have experience with, they've got a huge Terraform platform in it, which it's kind of like out of the box, like linters almost for your code. That'll tell you like, oh, you're deploying a database that's publicly accessible there, what you're doing. Get that feedback at even like pre-commit time. But you can then configure that for your organization and say, and there's also obviously cloud vendors have their own compliance tools. So like AWS config, and is it Azure config as well? I can't remember. I should know, I've set it up a few times. But whatever that one is, you get feedback there as well. This is more of a preventative thing. And you can do it with, there's a language that HashiCorp developed called, I think it's called Sentinel or something, which is purely a policy as code tool. Yeah.
For other policy stuff, you can do budgets. So
yeah.
A PR like, hey, this is gonna spin up something for like $5,000. Do you really?
Yeah. That's awesome. Yeah, that's a good shout. There's an open source tool that can look at your Terraform and go, this is how much this is going to cost you over the next week, month, which is great because like we go into organizations where I want to make an infrastructure change. I'm going to put it in a PR and I'm going to wait for someone in some infrastructure department to look at it and then go to the calculator and figure out how much it costs. What a waste of time. It's also, again, it's fallible. People who make mistakes. That thing is awesome. That's a good shout, Camille. Anything else? Any other questions?
Yep. You said earlier that you've got plan, apply, and destroy. Mm-hmm. I've used plan and apply. What does it destroy?
Yeah, so
when you don't declare something, it destroys automatically. I was a bit confused about that.
Yeah, so I didn't dig deep into how Terraform works, but behind the configuration and the actual resources, Terraform keeps track of something called state. That is, it knows what it's created, right? Mm-hmm. And it puts the reference points like the ARN in AWS and Azure into that state as well and says, here's what I control, here's what I've created. If you run Terraform destroy, it'll go through everything in your state file and it'll destroy all those resources in Azure, AWS, or whatever they are. Might not be a cloud provider, if that makes sense. Yeah. But obviously, if you wrote resources, didn't apply them and tried to destroy them, it would just go, I've got no state, so I don't know anything exists. It's really, is it on one of the slides? Oh God, there's all my animations come back to haunt me. There we go, is it? Yeah. So, there we go, this state file here, the top right. That actually doesn't elaborate on anything I just said, but it exists. Does that make sense?
Yeah, kind of. I mean, because the state file holds the state of the current system, so it should turn down everything without you having to say destroy.
Yeah.
When you apply it, so I'm still a bit.
Oh, so it's like, yeah. We'll talk about it later. Yeah, I'll have a few bevies and see if I can explain it better.
But by the way, it will just destroy.
Yeah.
It doesn't care what's there.
No, that's exactly. It's very aptly named. everything.
There's the production state file. Oh,
Yeah.
it's fine.
Azure gone. Any other questions? No? I think we're good. Cheers.
We need more microphones, don't we? These slides. These slides, by the way, are going to be on our Discord channel, which is quite new. So if you do want to see any of these slides, do check it out. And also, I know the screen's a little bit small. So if you're struggling seeing the code and you want to go back, view it on our YouTube channel as well, because you'll be able to see more, and the presentation slides are on there as well. But for the demos, definitely check out the YouTube if you're able to zoom in, and it's going to be a good quality as well. Right.
Yeah, on that code, we'll ask the GitHub on the PowerPoint.
Right, we're next. Do you want to put that on? I never used Canvas, but this looks absolutely amazing. That's working right, isn't it? Cool.
Yeah, the text is really walking, so you can do analytics, how the speakers walk
Yeah.
on stage.
I feel a bit jealous now that we've not even put a Halloween theme on ours.
Thank you. And hello. I think I just wanted to hide the.
So it should be that one and that one.
Thank you.
Press it hard.
Right. Thank you for the organizers for having me. And yeah, today I wanted to talk about designers and front-end developers. So it's like about design systems. Anyone have a designer? Nobody? Right. Anyone's a front-end developer? All right, a few. So I wanted to talk about what is a design system, and often the evolution of a design system is that back in the days you started with code, where there was no Photoshop, everyone was just like coding it. Then people started using Photoshop, they would like slice up the website. After that you had like Sketch, which was a lot more web focused, and then you had Figma, which introduced a lot more components that made everything a lot more fancy. And this is one issue with designers, is that it's very hard to work with them. They give you a massive file, which is, you look at the colors. You have like LM, extra, DM, light, GS. It's like, what is this? How I want to work with that? So a design system without a front-end developer is just an idea. And a design system has nothing to do with the actual design. The design and systems are two separate things. And then you have people say that, but it has design, the name, hence the name design system. It's like, it has also the system name. You have design is design, system is like programmers too, And then like a moment of silence for.
Like in the font.
So you can see that the difference between web designer and front-end developer is quite robust. You have the web development, which is typography. A lot of front-end developers think they are designers, that they make like a website, but the actual difference is the web design is talking about the typography, knowing what makes something pretty, knowing why the typography makes a certain feeling. That is something that is very important. Same like brand identity, color psychology, whether that's a green with like a friendly color. And on the other hand, you have front-end development, which is like more about actual programming, API integration, security, performance optimization. Those are like very two distinctive things.
I was missing the emotional context of how you feel about the booking page.
So what something means for a designer means something else for the developer. For example, when you talk about theming, this designer is going to think about the color psychology, how that emotion is going to evoke to the customers. And on the other hand, the front-end developer is going to think about the actual code. How do you take the, all of those colors and put them in code? Those are two different distinctive things. And you have this is what a designer is going to read, like the books of psychology of design, the laws of UX. And on the other hand, you have like a design, then you have a system, right? Two separate things. And this is what so a developer is going to read, learning system thinking and clean code principles and patterns, right? So you have a design system. In reality, it's divided into two different things. And mainly the design system was created for front-end developers, where the designers would create some Photoshop file, and it was meant to help get that design into the code. And that was a very hard thing to do for many years until now. We got Figma, which arguably made things a bit easier, but yeah. So if a design is, the design and a system is system, like why do designers, create a design system when they don't have the expertise building systems? It's like, who knows? So. And the most important thing in a relationship is communication. So anytime you speak with a designer, it's worth to figure out how they go about doing, for example, a button. How do they create a button in Figma, and how does that look in code? Because often you'll find that the two go head to head, which I'll show in the next example. And then I have a little, and the same goes with the naming convention and everything in between. So for example, you have a component that's, so someone might say that's a hero. Anyone want to guess how else would you call that? Just the component, like like hero. What other names do exist for that? Jumbotron from like Bootstrap, like a banner. So when you speak with designers or even like CEOs or stakeholders, there's like the terminology gets lost, because you say a hero to someone else and a banner to someone else, and they think something different. So it's really important to get a good structure that you can communicate. So maybe call it a jumbotron, a hero, banner, CTA, whatever works, you have to agree on something. And this is a project that I was working on for a startup, and this is essentially a Airbnb login flow, right? And that took the designer a few days to design, and it's something that I had to like look over every single screen and figure out what this is doing, which is like a big time waste, because a better approach doing that would be to say that the designer has copied this from Airbnb and just put a note that they want one change. Because that way you could have saved a ton of time instead of, you know. And this goes with a different components. So some people call this a modal, others call this an alert, a pop-up. You have like a model, dialogue, alert, pop-up. Again, it's something you have to agree with the designer, so you're on the same page. And then you have like, anyone want to know what this is called? Boo. So when working with designers, they often think that, you know, when you have a grid, they think you don't know how that meant to look like on mobile. They create like desktop, tablet, mobile, and that's also a huge waste of time, because this is very obvious, right? So you could have just make a desktop view, and if you need anything more complicated for the mobile, you can just take a note. So when creating a system, you can already use already existing tools like Tailwind CSS, Atomic Design Principles, ShadCN. Those systems are written by others. And even if you don't like Tailwind, as a lot of people don't, it's more about the fact that they have a set of guidelines that you can follow, and you don't have to actually maintain that. So for example, if you're using a ShadCN, and the designer is creating some components, it will be a wise idea to tell the designer that you're going to use ShadCN, and when it comes to naming things, for example, ShadCN uses background for background color and foreground for a text color. If the designer is using text color or whatever in their design system, it will make sense to use for foreground in the design project, because that's what the front-end developer is going to use, and just makes things a lot easier to understand. Otherwise, you're going to have a situation where this is a text and this is a foreground. What's the difference? So that way you can at least agree what you can do. And same with the namings, you can build a bucket list. So yeah, you can build a bucket list where over time you agree on certain namings and just reuse that across the project. You have some of the atomic design structure, which is anyone familiar with atomic design principles? So this is also, and the thing with this, some people might not like it, but the fact is that everyone has some philosophy on how to go about this. And whereas here you have a world-class person written a book about it, which means that you can just hand over the junior person and just read that book, and you have and Figma and React, or any component-based framework, is pretty much similar. If you look on the left, that is how it looks on Figma. And on the right, that's how it looks on, component-based code. You have a button, you have a type, and that type is set on the button. You have size, icon left, icon right. So some bits like state, that may be slightly different. However, the nice thing with this is you can actually synchronize all of the components, because when you convert a design system from Figma to code, you have to actually go over all of the components and figure out how to program them yourself. So when a designer adds a color, you're gonna look at, for example, a color variant, but you may structure that differently than the designer did. So it makes sense to synchronize the Figma namings and code namings, because they are pretty much exactly the same thing. And just so you know how that looks on Figma, this is how it looks on Figma, which is pretty much like a storybook front-end kind of thingy. And this is how it looks on in code and more code, which is the exact same output. So with that, since naming is hard and time-consuming, you can have one person that audits the name, so you no longer have to think about, where should that go, or if you're using atomic design, you don't have to think whether that's like, molecule, organism, atom. You can just ask ChatGPT, and over time you're just going to build a list of the namings of where that belongs to. So it's a one-time thing that you can build for your organization or yourself, and just search where that is. And you do never have to, you can like audit the names as well. So this is one example of synchronizing font names. Many times on Figma, you're gonna have random stuff. So with this, you have a clear pattern. You have like text small, text base, text LG, text XL. It's the same with the colors. The left one is something that's very easy for the developer to implement. Everyone knows that. There's already documentation written for that from Tailwind. Whereas on the right side, that's some random designer that created something that was meant to represent the left, give or take. This is not obvious. What is LM? What is GS? What is MD? Light? It's like, it's confusing. So, yeah. So
give us the hexes. We like the hexes.
yeah. So when the designer or front-end developer is creating a new project, it's a good idea for them to start the project together. Instead of just this designer being here, you get the lead front-end developer and actually help the designer build this system. Because designers, they don't build systems. They read books about psychology, about colors, about, they talk to customers. That's not building a system. Front-end developers, they have a expertise in building a system, and depending on what they're going to use, if it's like Material UI, Tailwind, Bootstrap, Foundation, Skeleton, it's a good idea to create this system around those frameworks. So that way the terminology and everything is on point. Yeah, so a good thing to do is when you work with others is that you can go out to your designer and see how they work and see how you work, and if there is something that you can do together, or do something better that will make things easier. Yeah, and a lot of front-end developers, they create some websites. And it's like, that's why they're not front-end developers. No, design system is really a bad name, because it's something more on the organizational level, on how you communicate and how you work, and how you work with others. It's kind of like, calling someone like a Bob. It's like, and yeah. Any questions? Or? All right.
done.
Uh-huh.
Cheers. Oh, I fell down there. Right, we're nearly at the end. We've got myself and Samson going to give a talk. Does anyone need a break or anything? Feeling like you need to get a drink or anything like that before we start the next one? I know you've been sat down, you know. We're out of beers. Done well. We've never run out of beers. I usually even store a spare crate in the car. So you've all done really well.
Preparing for your talk, so yeah, it's going to be all gone.
Yeah. Right, let's get this ready. Discord. Right, so the title of this talk is Reducing Web Hosting Costs and Choosing a Provider. So just so I can understand the type of audience I'm dealing with, who develops their own personal website here? A few people. Cool. Who wants to build their own website? Who's interested to? Cool. Got an audience. I guarantee by the end of this talk, you will all want your own personal website. So that's my promise to you. I'm going to try and get you there, and you're going to be on board. It's a strong ask, isn't it? Like, why would I want my own website? What good is it? So let's have a look. So when you choose a provider, you're going to have a lot to choose from. So when I started .NET Liverpool 5 years ago, I wanted a website, and it wasn't the best, but I went on, I got my own personal website. I thought, you know what, it's really professional. And to me, it's just a landing page. You go on there, my name, my references, great, fantastic. And then you go on and you're flooded with providers going, well, where should I go? I'm .NET, should I do it in Azure? Should I do it in Microsoft? And there's always a price and a cost to using Azure. You know, they're really good, but sometimes you need an app service plan. It's sometimes really expensive. Other providers are cheaper, but what do you actually get? So right now I'm going to talk you through some of these providers, why I use them, and what are the benefits of them. So one of the websites that I do, I'm a Christian. I go to church on a Sunday, love it. I built the website for them, and they turned around and said, well, actually, I offered to build the website for them. They already had a website. It wasn't that, we're on live stream. It was really good, but it needed some improvements. And they use Wix. And when I got on there, I'm like, well, I'm a programmer. Why would I want to use Wix? I've got to use boxes and move things around. And I soon, even as a programmer, someone who's, you know, probably not as good as Aurelio. If you look at his website, he is absolutely fantastic. Go and check out his websites he builds. But I'm moderately good at CSS. I'm moderately good at HTML and building websites. But jumping on that, I was really, really surprised just on how easy things are. I want a contact form, I pull it in. I want to change some colors. I want to make it nice. With a click of the button, the whole website went into a mobile-friendly UI. And you can't really do that, you know, with a site. It'll take you a long time to code. The price structures for this, like, it is expensive for what it is. You know, you get everything. It's made for a beginner user. So if you just wanted to start a business and you just wanted a website, you didn't want to put too much time into it or coding experience, you wasn't too bothered, and you had more than likely a few people who could work on the site. This is for you. Brilliant. And I absolutely love it. And everyone can get on board and work from that. One of the other providers I use for my own personal website is one.com. Really good. You get like this big ball of SQL servers, MySQL, PHP support, loads of other things. When I bought into it, I was like, it kind of encouraged me to do a bit of PHP and a bit of stuff. I'm not a pro at it, and it took me away from .NET, but I like learning new things, so it was good. But you get everything in there. One of the things that's really good about one.com is you've got unlimited emails. And if you ever come to look at providers making custom emails for businesses, you know, sometimes web providers charge you like after five, they'll charge you like, oh, well, give us £10 for that other email. You can make as many as you want. They are limited in size, only about 5 gig per email, so that's something to consider. Again, this is, you can go in, they've got a web builder, not as nice as Wix, but mainly you can jump on there, chuck things on a file server, they've got everything on there that you need, and you can go in and edit some HTML, do some nice scripts, that sort of thing. Where it failed and fell over is we wanted to use Git and push commits directly to one.com. They didn't support it. So you'd have no SSH support. So really, it's a lot of manual work. And this is where I kind of went, well, that's not really good for a community website like .NET Liverpool. But it's cheaper than Wix. You're looking at, for a beginner, if you wanted it, you're about £10 a month. So looking at, for our websites that we host there, probably about £100, £110 a year. Emails, web hosting, everything. You can't go wrong. So what do we look at when we look at all of these web services? So you go up to a client and you're going, well, what do you want? Do you want it good? Do you want it fast? Do you want it cheap? And they'll go, yeah, let's get started. We'll take all three. And they was like, well, that's not really the question. But what I wanted to do, I wanted to build this cheap, because the money that we get for this group, I want to spend on you guys, or want to spend on expanding this. And we want to use it all. So we want to make it cheap, but we also want the quality there as well. But can we do that? Can we put the quality back in and keep it cheap? And to do that, we really need to have a look at what is even going on behind the scenes around when you're building a website. So for instance, if you're with a provider at the moment and you just give them some money, you don't see everything that's on that website. You don't see something like this. And I'm going to talk through this. So when a visitor connects to your web page, you'll go through a little loop. You'll go to a registrar, and this is where your domain's kept. So this is someone's holding your domain name. You've purchased that domain. And again, that can all be bundled as one. It's then going to go to a DNS server, which is going to have the records. Where is my web page located? Where is my email server located? Basically just a load of directions on where I'm going to go. And that's its own thing. And then your hosting server, your file server. All my files are stored on this server. And we're going on a little bit of a loop in the tangent there. And you get all that offered by these web providers. And behind the scenes, you're like, as a developer of 10 years, I'm not afraid to say, well, what is a DNS server? Until I really got into the nitty-gritties of this, it amazed me how easy it is when you're working on it. So let's start on the DNS server. To be able to make this cheap, we need to understand all these components. So we're going to start with the DNS server. And for that, I recommend Cloudflare. It's an absolutely brilliant tool. It's got lots of functionality, which I'm going to go through now. But essentially what we're doing, and you can do this with your current provider, all you've got to say, any web provider you're with is in blocks. And you might not realize that, but they're all separate. You can take your DNS and you go, well, I don't want to host that DNS with you anymore. I'm going to move it over to Cloudflare. So I move my DNS over to Cloudflare. Great. What does that do? It means that I get all these records in. And basically, these are all of the directions of where the requests need to go to fulfill. So this DNS, now Cloudflare, knows exactly where I need to go. It knows my IP routing, so to go to the web server, oh, you want to go over there. And it just directs these things around. And on the top level, these are the 5 record types if you're going to do this. Help sheet. You come here, and you don't really need to know these before you start, but it's nice to look at them. The first 2 are just basically saying, right, well, if I've got a record for these 2 types, I'm going to come to an IP. So if I go to .netliverpool.org.uk, I'm going to route it to either an IP or an IPv4, and that's essentially what it is. The CNAME is, I'm going to direct you to another host name. MX records are email servers, so I need to go to this email server to send an email. And the text records are just some notes, essentially, on your website. They're really good for confirming that you own the website. So a lot of the providers that you get, they'll probably say, well, can you go and put a file on that website to prove it's you? You could. That's one way they can verify it. Or you could just put a text record on your website, and straight away they go, oh, he's just updated the DNS, so you must own that website. So in a nutshell, it's nice to have a broad concept of what these are if you're going to do it. And then you do it, and all of a sudden you're like, no, my website's broke. What is this? And I've only moved the DNS, and should I just revert it back now and just stick to my £100 subscription? But Cloudflare is absolutely amazing. So what it's done is detected that one.com had an invalid cipher on their HTTPS certificate. And the HTTP certificate is basically made of these ciphers. They use it for decryptions, that sort of thing. And there were one that Cloudflare just turned around and went, well, we don't really want to support that one that they're using because it's not secure. So, and Cloudflare are the professionals in web security. So I think I trust them. Well, how can I fix it? Well, Cloudflare can actually not use a HTTPS certificate on the web server and have the ability to generate their own and just do the request and serve their own HTTPS certificates with better ciphers and do what they want. Brilliant. Another thing they can do, now this is interesting. I just thought, God, this Cloudflare is just a DNS registrar, and I wasn't expecting to go into half of this stuff when I went in. But they're not just that, they are way more. You can do tunneling. Now, if you've ever hosted anything on your personal computers, so whether that's a web server, hosting, you'll know it's an absolute nightmare, right? You've got to go onto your router, you've got to forward ports, you've got to open up ports, and then all of a sudden you've got security risks because you've just opened up your firewall to allow things onto your network, and I wouldn't really be bothered with that. Tunneling is a way to, they just give you a bit of software to install on your server, on your PC, and they go, what port would you like us to use? And they deal with everything. So what I did, I set up a tunnel onto my server, and then I can now go on to plex.joshduxbury.co.uk, which is my website, and access Overseers. Overseers is running on my server. Absolutely amazing. So what I can do is I can log in and browse through all the movies and everything there. I can then add them to my library, and then it'll rack up and then tell me when them movies have come out, so then I can go and buy them or, go to the cinema and watch them. Brilliant tool. How cool is that? And one other thing I didn't notice as well is just how many bots visit your site. It is ridiculous. It slows down your site. They're on there maliciously. 90% of bots, aren't Google on there really just trying to scrape your website going, oh, this is what we want to display on the group. They're actually there to maliciously attack your site. So what you can do, you can add rules onto your site. So for .NET Liverpool, if anyone's outside of the United Kingdom, we show them an automation bot cipher thing saying, can you prove that you're human? You guys won't because you're in the UK. If there's a threat score, and straight away, if they try and access anything on .NET Liverpool, that is an admin, /admin, or show me your WordPress admin site, you will get blocked. If you went onto anything and tried to go onto any URLs that you're not supposed to, that would give you admin access, we'd block you straight away. In your IP, you'll never be able to get on there again. You have to send us a please and a message. So don't try it. And that's Cloudflare. There's more you can do. Go check it out. I'm only touching the surface in this talk. Your registrar, where do I want to put my domain name? Namecheap. So we move that over to Namecheap. Why? Well, because normally if you're getting things in a bundle, they go, well, you're less likely to go and want to change. So we'll put an extra £5 or £6 on there because, who else are you going to go to? And they'll price everything individually. So just by moving your domain name to somewhere else, if you are in a bundle, just saves you money. And then if you miss a subscription or they hike the price, you will always have the domain name. And you will have that. Plus Namecheap have a really good mobile app. If you want to buy more domain names, I could buy every single domain name in there. They give you 1 year free. If you've got an existing domain, switch over to them. If you've got 2 months, 1 month left, because you'll get another year free. Who doesn't like free? I do. Hosting service. Okay, so where are we going to host these files? And for that, we chose GitHub Pages. I like it. And this is where it all starts fitting together. So all you need to do is go onto your GitHub account, give it the name of the repository, and say, I want to start GitHub Pages from my master branch, or something along them lines, and then you've pretty much got your website hosted, give or take. But generally, there's a lot of instructions online. I'm not going to go into it on this talk, but within 15, 20 minutes, I had my GitHub Pages hosted, which is really good. The next thing you might be thinking, well, my emails. This was the tricky one, and this almost collapsed my theory around trying to get the cheapest domain, because emails, you need an email server, right? So, yeah. So what did we do? We used MailJet. With MailJet, you get 6,000 emails a month, more than enough than what we use. So we moved our email server. Yeah. So we moved our email servers. You can upgrade it. It'll cost about £15 more, but 6,000 emails for free. Well, I'll take that, MailJet. Thank you very much. If you're watching, come and sponsor us. We like it. So we're sending more. And this in itself is an email service. So by separating these bits out, not only are we saving money, we are incredibly more powerful because we can set up mailing subscriptions. The other providers, they have a limit on how many you can send, not MailJet. You can send as many as you want. They're a good price. So that's what we did. But I want to send it. So how do I do this? So what we used is Google. Google offer 15 gigabytes of free email web space. Free. Set up a Google account, got your email. But you don't have your custom email. That's what you want. In your settings, you can go to Send As and then set up a new SMTP server. So I can now send emails from my Google email address, but send it as joshduxbury.co.uk or joshduxbury.netliverpool.org.uk for free. I've got everything for free. Perfect, and it's nice. Google Mail, if you've not noticed, is absolutely brilliant. They do scan your emails, which you don't like for advertisement purposes. So, but for free, there's not really much in there. So go ahead. And yeah, it's really nice. So we got the email server for free as well. But was it worth it? So after learning about DNS, after learning about moving the registrar, moving everything, was it worth it? Let's have a look. This was the website we were transferring. This is the website we were costing us £100, over £100 a year. It's not a lot, right? But you want 3, 4, 5, 6, 7 websites. It's all going to accumulate through the year. We ended up getting this website now for £7.99 a year with more email storage, with better security. And I just want to say a round of applause to Samson as well. He has done an absolutely fantastic job on the GitHub as well. So thank you so much, man. This is the website we've got today. When you scan the vouchers and stuff to win, which I can't wait to show you because Samson is, again, he's done a really good job there for the name picker. He's going to blow your minds. The website is all hosted on GitHub. It's using Jekyll, which is, it's Ruby, but it's pretty much all sort of, how would you say, Samson, templated out. You got to go in, it's a bit of code, but generally you get things up really, really quick. It's got everything built in. So you can, themes as well. Even if you want to do a CV, you could now do your CV on GitHub, I was thinking about it, and just post it for free on a website. And if you wanted to, if you wanted to make it look more professional, buy a £3, £4 domain name, and you've just got this for free. So, it's really good and powerful when you put these together. And I'm not even, the idea of this was to get everything as cheap as possible. It ended up being more powerful than we could imagine. And other than that as well, we learned a lot more about Cloudflare than we ever could without doing it. And Cloudflare is such a powerful tool, so powerful. And a lot of what we've done is only possible because of Cloudflare.
You didn't actually put costs on.
Yes, it was this time. So pros and cons, $7.99. There we go. So with the pros, there's more features with Cloudflare. Even on our submission box now, on our old website, we had thousands and thousands of bots posting things for our contact forms on our blogs. And we had just plugins. It was like, put this bit of code in there, and if it's a bot, it won't let them submit. And we've never had one since. And that's really important because I don't want to use MailJet, 6,000 limit on an email, and half it's been taken up by bots. So very important we got this sorted before we let loose with going over to an email subscription that's going to charge us per email. Only $7.99 a year. The website's under source control. So Samson working through the night and me in the day, we were tag teaming it. So, really good to have that back out control, seeing what Samson's doing. Well, how have you done this? How have you aligned this? And just all this other cool stuff. Decoupling allows as well. So if I want to change my domain name, I could just change it for another provider. If I want to change my web hosting, I am completely decoupled now to be able to make them changes, and I could do whatever I want with it, and through just adding a few DNS rules. And it's a good learning curve. I'd recommend anyone who's going to sort of want to do this, go and do it, because you'll be amazed of how much you'll learn in the process. The cons, there's less support. So if you do sort of move stuff away, we was in a partial state where we were like, the handshake failed because of the cipher, which I told you about. I got onto one.com and they just turned around and went, well, your DNS is not with us anymore. We can't help you. I'm like, oh, okay. But it's your cipher that was wrong. but luckily Cloudflare to the rescue. There we go. So you do get less support because a lot of it's not maintained by that one provider. So you do have to do a little bit more, but once you get over that hurdle, it's really good. Increased setup time, especially for emails. You can't just like log into a provider, you've got to go into Gmail, set up your SMTP. There's a little bit more setup, but again, once you do it, 15 gigs worth of free emails and beautiful, can't go wrong there. There's no HTML builder like you would get with Wix. It's not going to be as quickly. You do have to do some coding, that sort of thing, but there are ways to improve that. There's Hugo. So if you're looking for a no-code approach, have a look at Hugo. They are essentially just like a builder platform where you can go in and got like a CMS, you're like, I want this. Really good, but then you're limited to what you can do. Because with a CMS, you can only do as much as you can that the CMS supports. With Jekyll that was done, we can fully customize it. So our website's fully customizable and it's everything on there we can change, we can do whatever we want, which is really good. Limitations is because it's on GitHub pages, you are front side, client side. You've got no back end until Samson's talk. Implementation, cloud provider. Implementation could change per provider. Yes, so that means that if, I just give you this talk now, I could do another talk on exactly how to migrate and do exactly what I've done, but every provider's different. If you're with another hosting, the way you change your DNS, the way you go through their web platform to do this, it's all different. So there's a bit of a learning curve to try and find out. Unless you're in like the top 10 webs providers, really it's a lot of self-learn to try and go, well, where's my DNS settings? How do I get them out? A bit of changes there. And GitHub Pages as well, this caught me out. GitHub Pages has a 10-minute CDN cache. It's free. They're giving you web hosting for free. It's nice. They do have content delivery networks where they store things regionally, and then they only update them so much that the servers don't get hammered with requests. They only update them every 10 minutes, so you could be lucky, but every time you push a change up that gets deployed, you could, if you've just missed that window, be waiting 10 minutes. But again, $7.99, what can you do? It's worth putting a kettle on, making a brew, and waiting 10 minutes. So that is my talk, thank you, and I'm going to hand you over to Samson.
How do I click this on? Thank you. Hi guys. My name is Samson. Like I said a couple of times, pretty much excited about today's meeting. For the past couple of months, when I've been up, I've always introduced myself as a volunteer. But this month I've been promoted to a co-host, so pretty much excited about that myself. Today I'll be talking about something you all probably use, whether you're developers or not, and those are productivity tools. My very first meetup, I did have a conversation with someone, and I like reading a lot. I've asked for recommendations for books, and he recommended a very interesting book, The Pragmatic Programmer. And something that stuck with me, very important, was about a craftsman tools. I've had these images up for an analogy, but while I was sitting there, I thought of something else. Say back in the days where farming was about hoeing, we probably had people that were very knowledgeable about planting, good time to plant, whatnot, depth type of soil. But a good farmer with a hoe knew exactly how much effort to use when trying to dig out the soil and whatnot. And possibly you could know a lot about farming, but if you didn't know about how to properly use a hoe, you probably do the same work in a whole lot more time. And when you're done building up the ridge and the mound, it maybe breaks off after like a week or so. And a very important point, a good craftsman is one that knows his tools, not just the trade, but the tools of the trade. And as developers, we also have tools that we need to know to be better at our jobs. Chris has discussed about automated testing and building with Terraform, IDEs like JetBrains, source control, and whatnot. But there are a different set of tools that we use a lot, but we do not focus on or bother to learn to optimize, maximize, make better use of, and those are Office tools. And a couple of people probably ask, I'm a developer, why should I be bothered about Office tools? But for the very first reason that you do use them every day, be it Teams, your calendar, daily emailing, those are productivity tools. But the survey is by Statista, I think that's the website. They show a prediction of current usage from 2016 till date, 2024, and the prediction till 2029 of Office tools among productivity softwares worldwide. And Office softwares are the most used currently in the world. And I think we all agree they're very important for collaboration and operational management currently in industry. And of all the Office tools, the biggest companies or the biggest market shareholders are probably Microsoft, definitely Microsoft and Google, with the 365 and Google Workspace suite of apps. And what do we use them for? Communicate, planning, survey, analytics. There's a whole world of products and more coming up every day. Probably don't know half of them, to be honest. And probably ask again, why should we care as engineers? Our job as engineers basically is, our value as engineers is we provide automation. Processes need to be automated, and that is what a lot of softwares strive to do. And these products, these particular companies, they provide a couple of tools that enable us automate these products. With Microsoft, it's the Power Apps, Power Automate, Office scripts, and so not what. And with Google, very simply, App Scripts enables you to hook into a whole wide range of tools and automate as you deem necessary. The only difference probably is that with App Scripts, you're writing a lot of code, and with Power Automate, you're probably just syncing up processes with, it's basically just like a pick and drop thingy. And again, for people still asking, it's still a very important question, why should I bother? I'll show you a very practical example. So for returning members, you've probably noticed the giveaway form, the survey we always do every month for our JetBrains giveaway. And sometimes very tacky when we do the raffle draw. We use a mobile phone, try to get the names on there. We have to copy the names every day from the sheets, try to, get it all hooked up. And this month, with the changes just made on the website, I've tried to make things a little bit more automated. It is a developer meetup anyways. So what have we done? Google allows you to create forms that automatically gets hooked to a sheet that is generated from the form. You get the information directly through the form. And what do we want to do with that form? Create an API. Pretty much simple. How do we do that? Google Apps Scripts connected to either any particular product you want, literally any product in the Google Workspace suite, you can connect it to it, hook up to it, create up an app script that you can deploy with a HTTP trigger, mostly get and post requests. It's basically simple syntax. It's almost like JavaScript, to be honest. You're not really doing anything simple, extra complicated with it. Basically hook up. For this particular case, we've hooked into a spreadsheet, just gotten the data on it and sent a response back to whoever's calling the GET request. Setting this up was actually quite easy. You just needed to set up accounts or projects on GCP, hook it up to the project and set it up as a web URL. For a particular use case, we've deployed this as a web URL rather than an API, and you might probably ask why, and that's because our website is basically browser-based, no servers going on it. With an API, you would need to set up authentication, authorization with the whole IAM and Google credentials, and we didn't want to do that. We wanted free access. So with a web app, you basically set it up, let anyone access the application, deploy the application, and voila, you have a URL functioning API. Everything is all set up. How do you use this? Well, pretty easy, same way you use any API. Simple GET request, and everything is hooked up. But then again, it's easy till it's not. Something, a little gotcha we've come across while trying to implement this is you've got the hooks with the GET requests, but it doesn't work the same way with the POST request. And this is because Google's, they don't send you a response directly through the API address, so they send you to a one-time address that's set up to, it's just for security, send you to a one-time address that's set up to send back the response to you. So because it's a redirect, there's the whole browser security, so because of CORS, you get a whole lot of CORS errors. Only thing I found that works is to ensure any request you're making allows redirecting, and send the content for post request as text rather than JSON, because you can also convert back to JSON on the posts on app scripts. Easy peasy, I think. Anyways, that's not all. You also get extra support for this. You get login and monitoring on GCP. GCP monitors and logs. You're able to monitor your app performance and any sort of logging you want to do. So it's not a black box. Sort of a black box, or not so much of a black box anyways. And other things you could use this for. Really, really interesting thing I've seen someone do is set up a chat app with their emailing app and their calendar. Google Chats, go on Google Chats, discuss with the chats. Everyone does AI now anyways. Discuss with the chat, ask about your scheduling or your emails, and quick responses. You don't have to use your emailing app, although I probably definitely would just still use my emailing app. Anyways, the possibility is endless depending on what you want to use it for. These are apps you use every day, and they are literally endless ways you could use it. Cons, every good thing has a bad side. You probably wouldn't want to use this for very large projects out of company, out of personal usage, because it's not really much in the way of scaling or doing much for a lot of customization. Same goes for security. A lot of the security permissions are not customizable because they're set up by Google themselves, because it has to be secure. And last is vendor locking. I mean, that's pretty much obvious. If you're using automated tools from Google, you have to be using them on Google Apps. You can't switch hosting or do any fun stuff you want to do. But again, it all depends on the use case. You're probably not going to use this for a big enterprise application or something you're shipping out. It's probably something in-house, in companies, very quick to set up, easy to pull out, and everyone is happy. Thank you for listening to everyone. Last thing, I'm currently searching. In case you're hiring, definitely feel free to mail me. I have a .NET email now. Thank you very much, guys.
One quick thing for those who might not know, what's GCP?
Google Cloud Project.
Cool. So, again, he's done some amazing work, Samson. Alex, get your CV. we need to get him a job because can't let that talent go to waste. For those who want to see it in action, so this is something that Samson's built on the website. Front end app uses app scripts, connects to that, and it's going to connect to the spreadsheet which you've all filled in for the raffle. And that's going to pull back in and random name generator, which is just pretty cool. Less messing around. Have you got the license?
Yes.
Cool.
First question is, has it got a spinning alpaca?
I don't know. Let's have a look.
Only?
Oh, it has.
Oh, it got a spinner of sorts.
Oh no, it tricked me. Martina. Almost. Martina? There we go. Well done. Congratulations.